Okay. Bring these pieces up together. There we go. Questions. Okay. Oh, people are starting to trickle in. Oh. Hey, Annika, did you see Carol's there?
I do. Cool.
Hi, Carol. You need to catch up at some point. People are trickling in. I think we'll wait a few minutes and let people in.
There's already a comment in the question chat, Brendan,
Oh, okay.
or the question.
Yes, I agree.
Brendan, I can't see comments or questions. I'm only looking at my presentation. So if anything I need to answer, let me know.
It was just a comment from Carol to me to say that we need to catch up. She was just responding to me.
Okay. No, I'm just saying if
No,
there's anything for me, let me know, please.
Got you. I'll monitor the questions and yeah. But you can see the attendees list, right?
No.
Oh, you can't see that either as a presenter?
No, I'm looking at I can exit out of my presentation, then I'll be able to see.
Ah, I see. No, I don't do that. Well, we have 21 people so far, which is far more than the last time we had a presentation.
Well, it's an exciting topic.
I guess. Well, I think it's new. People, these technologies are not widespread yet, so I think. So that's why I thought this would be a great topic for catch people's attention. People are still trickling in up to 22. Oh, 24. My goodness. Okay, I think it's maybe slowing down. Okay, Annika, do you think we should, oh, I guess a couple more just popped in. Okay. And perhaps we'll get going, okay?
Sounds good to me. Thank you.
Okay, yeah. Although they're still trickling in. 27. Okay, let's get going. So my name is Brendan Hemley. I'm the chair of the Advanced Public Transit Systems Committee, APTS Committee of ITS Canada. And as part of the committee's activities, we periodically invite speakers to make presentations to the committee and to the sort of wider community of people interested in transit ITS. And so today we're going to have a presentation from Igor Zaslavsky. He is manager of transit management systems at York Region Transit, which is the Public Works Department of York Region. He's worked there 17 years, and I've known Igor for a long time. He's been involved in many different ITS systems. He's responsible for the research, design, and implementation of all these systems, and the management and system maintenance contracts, as well as operations, maintenance, and support for all of these programs. Today he's going to talk about two what I thought were very interesting, not that widely existing systems or widely deployed systems, sort of a driver assistance system and driver support system and collision avoidance system, particularly relevant for electric buses. And I thought that was particularly interesting. So I will turn off my camera and Igor will make his presentation, and then we'll have a question period afterwards. Thank you all.
Thank you, Brendan. Can everyone hear me okay?
Yep.
Okay, well, Brendan, thank you for the introduction, and thank you for inviting me, Brendan and Yannick. So my name is Igor Zaslavsky, as Brendan mentioned, and I'll present what we have done at the York Region Transit with the driver support and collision avoidance systems. Just to start off, we were very happy and proud when Yannick shared with us that York Region Transit was mentioned in or published in the ITS article, and they published two systems, driver support system and collision avoidance and pedestrian warning systems. And then they invited me to present, and this is what I'm going to be providing you with some more details what we have done. But this is the article, and if you're looking for a link to the article, let me know.
Igor, I don't see your presentation. Bianca, do you?
No, I don't.
I just see your camera.
That's strange. Can you see it now?
No.
No.
How about now? Okay, show my screen. How about now?
Yeah, there it goes.
Yes.
Perfect.
It's funny, we've done 2 dry runs and now it didn't work.
All these technologies, they always, that's why you have to have departments to sort of manage all this, because they're so complicated.
Yeah, you know, the share screen icon or button was behind my presentation, but now it's good.
Correct.
It's good. All right,
no,
so you can see the article.
Yeah, we see it fine
okay.
Now, yeah.
Yeah, thank you. So as I was mentioning, this is the article that was published in the ATS magazine, and anyone who is interested to see the magazine or the link to it, let me know or let Brendan know, we can share that. But we were very proud, we've circulated that internally, and we've also shared this with our vendors and partners who worked very closely to implement these solutions. So driver support system, we've implemented driver support system working together with our long-standing partner Init. We have CATIVL system by Init, and we work with them to, we'll help them to develop the driver support system. And what it does, it monitors and improves driver behavior. And what it does, it reduces number of incidents, falls, and helps as well as helps with wear and tear of various mechanical parts. And the idea of the system is not meant to be punitive, but it's just to improve safer driving techniques. And I'll get to that later in the next slides, but we collected data and we monitored the trends and all the safety events. And after implementation of the system, we saw a rapid decline of these safety events. So, and I'll play the video in a second, but on the mobile data terminal in the right corner of the screen, you can see the icon, which will appear, and it's a visual indicator icon that will appear and will show the driver if the driver is doing harsh braking or harsh turning, acceleration, or revving. The highlights in the right, in the left corner, it just shows you what type of alerts we provide to the driver. And then our safety and training department, they meet with, we're monitoring top 10 performers or worst 10 performers. And then our department, safety and training, they meet with them and they help to reinforce safer driving techniques. Let me play the video for you.
One of the technology initiatives that we've implemented on transit buses to help improve the experience of travelers, as well as the efficiency of the vehicles, is the driver support system. Bus operators receive direct feedback on their driving behaviors through the mobile data terminal, which provides a graphic indicating how it is that they're driving based on 4 specific icons. Turning is recorded when the bus is making a left or a right turn, and the G-force on the turn exceeds the threshold that's desired. To help improve fuel efficiency, 2 icons are representative. One for harsh acceleration, which is where the operator accelerates the vehicle, creating the risk that the traveler may fall while attempting to take a seat or get up after departing or arriving at a bus stop. In addition, a second icon will be produced or displayed on the screen when the accelerator pedal is pushed to the floor 100%. This creates a scenario where extra fuel is introduced into the engine and is not burned efficiently. Combined, both of these icons help reduce the risk of a passenger injury, as well as improve the fuel economy of the vehicle. Braking is a maneuver which requires the bus operator to use forward planning skills and momentum driving techniques to anticipate the changing of a light and traffic patterns ahead. Should the driver exceed the expected threshold or the set threshold for the braking limits, thus creating an aggressive or harsh brake application, an icon will also display on the MDT terminal. When at the end of the line, operators typically have a layover period. Under normal circumstances, we adhere to a 3-minute idling rule. If the vehicle should idle longer than that period of time, an icon is displayed on the MDT terminal, requiring interaction from the bus operator to acknowledge that the bus is idled in excess of the required time frame. The icon reminds operators to adhere to the anti-idling policy to help the region achieve its greenhouse gas emissions and fuel efficiency goals.
All right. Did you hear that okay?
Yes, we did.
Okay, good. And this Sean is our safety and training program manager, supervisor, and as he mentioned, the system, of course, helps with reduction of greenhouse gas emissions, and it's part of our greener strategy and approach as well. And it aligns well with our plan to electrify the fleet, and again, as I said, reduction of GHG gases. So the system itself, it is integrated as part of the in-it onboard computer, so there's no additional equipment required. It's a software that is integrated with the onboard computer. And what we're doing, the next slide actually shows various data that we collect. We download all the data and we monitor trends and we provide analytics depending. We'll look at the driver's performance. We'll look at maybe the certain environment that creates not such safe driving techniques or vice versa. So this is just a snapshot to show that the amount of data we collect. And we also look at reduction of idling. And we, as I mentioned before, we saw drastic decreases in terms of idling hours or safety events. So it has significantly improved. The next system that I'll present is collision avoidance system. But just to mention, actually, the driver support system, we have it on all our vehicles since I think 2018, and now it's part of our standard deployment by OEM. So whether we're getting it from New Flyer Nova, it doesn't matter. The driver support system will come already configured. Now, the next system is collision avoidance and pedestrian warning system, and we work with Rosco to install Mobile Eye collision avoidance and pedestrian warning system. We've had one of the, I think it was a third generation of the system. That system didn't perform very well. It didn't work well in the low light conditions and bad weather conditions. So we work with them, and eventually we've installed the fourth generation of the system, and now that system works really well. We've installed it. We've operationalized it on electric vehicles. We have 12 electric vehicles right now, so that system is installed on electric vehicles, and we made a decision going forward to install that system on all the future procurements. Now, that system, what we have sensors on both sides of the vehicles and in front of the vehicle on the windshield that monitors cars, pedestrians. The system is very intelligent and can detect cars, pedestrians, cyclists. It monitors speed, it can detect blind spot and head-on collision monitoring and lane departure control. A lot of these features you see in regular cars, but not much of it yet exists on public transit. And then there are indicators inside the bus. So we have, if you can see right here on the A pillar, we have an indicator, and it lights up if the system detects a pedestrian on the right and left side of the pillar. And also there is a monitor, an indicator on the windshield to indicate the speed, alert if there's a head-on collision, and shows number of seconds remain to the collision if the driver does not apply brakes. The system is especially benefit, or the system provide benefits on electric vehicles, especially because the electric vehicles are quiet in nature, and when the cyclists or pedestrians are detected, the system provides an audible signal from the external speakers, and that's what we call pedestrian warning system. So because electric vehicles are very quiet, it is especially important. People are wearing headsets, listening to music, not paying attention, crossing the road, looking at especially the kids, they're looking at their smartphones. So a pedestrian warning system, the audio signal, is very critical to pedestrians when the pedestrian is within the vicinity or the danger zone of the vehicle. But the next thing, what we've done is, and that was purely our initiative, is to combine both systems together or integrate both systems together. So we take the safety events from the init cat AVL system or init driver support system, and we pass it on. The other way around, actually. The events from collision avoidance system. So if the cyclist or pedestrian is detected in the near collision zone or in the basically on side of the vehicle, but within the collision parameters or thresholds, that we pass those safety events back to our init system, and we match the timestamp. So we'd like to see what is the driver reaction to safety event of the collision avoidance. So if the vehicle comes very close to the pedestrian, we'd like to see whether the driver was slamming the brakes or trying to turn or whatnot. And I'm not sure if you could see on my right-hand side. Can you see on the right-hand side the window with timestamps, or is it blocking by the?
Well, you can. I mean, it's there. People can just.
Okay, I'm gonna move. So
if
you look at
the arrow and it moves off screen.
Okay, so if you look at if you look at 513, for example, there is a collision warning detection. That means vehicle came close to a potential collision with a pedestrian, and we can see it on a map. So we can, all the events are geocoded, so we can see on a map where the event has happened. But also we could see, because we map it to the events from the driver support system, so we could see there was at 5:13 and 10 seconds, there was harsh acceleration, so the vehicle was accelerating, and then a pedestrian was detected in a warning zone or a collision warning zone, and then the driver applied harsh braking, and then the driver accelerated again. So this type of integration helps us understand the driving, again, events, driving techniques. And in case of an actual accident, we could see what the driver was doing. Was he accelerating prior to the accident? Was he braking? Was he turning, revving, etc.? So those are the things that would help us in accident investigation, but even in coaching, because what we have done, it's also, everything is reported, so we collect the data, and we will highlight or flag all the events where we see collision warning messages when they are in the red zone, meaning it's almost a collision, and then we will match it to driver support system events, and then we can, our safety and training can speak with the driver again by coaching and providing direction on how to basically conduct safer driving techniques. But both systems, of course, improve the wear and tear of the vehicle. Both systems provide a reduced number of incidents, accidents, slips and falls of passengers, and provide additional safety to all the travelers. Now I'm trying to, okay, so that's pretty much it. That's what I want to share with you today. If you have any questions, let me know.
Well, thank you, Igor. Let me turn on my camera. No, I'm sure well, I have lots of questions, and we do have some questions already. So thank you very much for just the overview. First question relates to the icons on the monitor on the right. Is there a safety concern with having these small icons way to the right of the driver's direct view of the road, having them, in other words, if they look away from the road? Has there been any issue with that?
We haven't had any issues. So both of these systems, before we put in production, we installed it on a subset of few vehicles, and we had few drivers operate it and provide feedback. So we work with them on configuration, on look and feel, on thresholds. So once we have done a fleet-wide deployment or a larger fleet size, we haven't had any negative feedback. We try to capture it during the implementation. So to answer the question, these icons, they don't provide any disruption. They only appear as the events exceed thresholds. Mm-hmm. And actually, drivers are so used to them, they appreciate it because it's a reminder for them not to speed and to have more defensive driving, apply more defensive driving techniques.
Right. No, I mean, these are pretty common in cars, new cars these days to have a sort of eco drive system of some sort, but the icons are pretty cool. Another question.
And just to add more, because it's not just these icons, we also have icons on the pillars right here that light up if pedestrians or cyclists are detected. But drivers have known how to properly operate the vehicle and monitor all of the signals and all of the indicators. So no negative feedback, only positive actually.
Great. Question, what is the quality of the warning systems in terms of percentage of false warnings or missing warnings? Have you any concept about that?
So very, very good question. Initially, we had to work with driver safety and training to exclude all the false positive events and make sure we calibrate all the thresholds. So right now it's pretty reliable, but we had to do some work to make sure that they appear properly. We apply proper G-forces and a calibration of G-force sensors, etc.
I guess a question related to that. The fact that, you know, the buses along the corridors in sort of more dense urban areas, let's say along Yonge Street, is it not picking up things that are on the sidewalk so that it would be activated all the time?
No, it's within the threshold. So it detects the speed, velocity, and a bunch of other things. So it actually monitors vehicle speed and direction. So it won't light up if the pedestrians are walking parallel to the vehicle.
Okay, oh, that's cool.
Within certain distance.
Certain distances, right. Could you talk a little bit about the sort of the installation of the bus. I mean, I see in the slide you've got right there, the color indicators are actually in the dashboard, looks like. So there's sort of that kind of adjustment, you know, installation, but also were these, I mean, the G-force detector, was that already something in the vehicle? I mean, the sensors detect it, but well, so the sensors are more optical, aren't they, or radar or lidar? Could you talk a little bit more about the sensors and whether any new elements had to be added, like the G-force measurement?
So for the driver support system, I don't believe we had to add anything else. Everything is read by onboard computer, Copilot PC.
Okay.
As far as the sensors for collision avoidance, I believe that these are optical sensors. But I have to get back to you if I need to confirm what technology they're using. It's not regular cameras. These are sensors, I believe, optical, but I don't think it's a radar-based. We did explore another radar-based technology by Protran. Actually, before we've decided on collision avoidance by mobile eye, we've piloted 2 different systems. Actually, 3. We've piloted, we piloted Clever devices, we piloted Protran, and we piloted mobile eye previous iteration. Protran, I believe it's a radar technology. It's not as, at least that one, it was a few years ago, probably 5-6 years ago. I'm not sure what they have right now. But back then, the system wasn't sophisticated enough to determine or differentiate between cyclists, pedestrians. There was no head-on collision. There was no lane departure. It was just object detected or not. And it was scanning the front of the bus using radar-based technology, I believe. Mobile eye proved to be more sophisticated in terms of it was able to differentiate different types of objects. Now, Clever devices, again, I mean, they may have a smart system right now, I'm not sure, but back then, the system was pretty passive. It was just installed and used based on the steering wheel geometry. So as the steering wheel was turning, it would create an audible signal. And we got a lot of negative feedback for that because it would create a sound regardless if there's a pedestrian or not. And we would get complaints during the night hours. If the vehicle is going through subdivision, the vehicle would create an audible noise just because the steering wheel is turning. So we've analyzed different pros and cons of each system, and we've decided to proceed with mobile eye.
Okay. No, I've heard that sort of complaint too. Oh, we got a bunch of other questions. So, how challenging was it to integrate the collision avoidance system with the init CAD-AVL?
Well, thanks to init, they've done a lot of work and helped us out with the integration. Of course, it comes with its own software development challenges and creativity, but we've done it. And the idea was, we came up with the idea because when we installed a standalone mobile eye system, they have a software on the cloud, and all the safety events are transmitted to the cloud, and they have a subscription-based software. That would add to additional costs. We already have a SIM card. We already have a cellular signal with for CAD-AVL, for init CAD-AVL. We did not want to install additional SIM card just to upload safety messages for collision avoidance and to pay for another cloud-based software. So we've decided, is it possible to bring all those safety events to init and then combine them? Because we could use the timestamp, that map that you saw, hang on, right here, that comes from init. So we get the safety event, we get the GPS coordinates of the safety event, and that's all we send to init. And then we map timestamp with GPS coordinates by init, the vehicle by init, and all the other information. So we actually, by integrating that, we've got even a better product than just having a standalone app of collision avoidance. Because the point of, we try to determine what's the value of that system. How do we know if it provides benefits? I mean, we know it does, but how do we prove it? By integrating it with init, we were able to actually know, well, or how can we mitigate or resolve issues or improve driving only by integrating with Init to see what the actual driver was doing, what were the safety, what were the triggers.
Yeah, no, I see.
But now, I mean, we've paved the way, so we have the interface is there for anyone who would want to have that system in place by Mobile Eye, and if Init is the vendor, I mean, the interface is there. They would have to just work with Init to implement it.
Right. Okay, another question is how long was your pilot before deployment of this technology to the entire fleet?
So initial pilot was for which system? Sorry.
It doesn't specify, I guess,
Okay,
which one.
So collision avoidance pilot, we ran it for a couple of years. The challenge was also during COVID, everything was paused. We weren't sure how to proceed.
Right.
But we ran it for a couple of years. The idea was to make sure that we do it for to cover all the seasons and weather in Canada. We want to see in the low light condition during winter months, during the fall months, etc., and how the system responds.
Right.
Will the sensors be impacted by dirt, dust, wind, snow, rain, etc.? So it took us actually. Well, first we've piloted different systems. So first we had to decide on what technology we want to go with. Is it radar? Is it sensor? Is it passive? Once we've decided that it will be sensor technology by Mobile Eye, it took us another year to make sure to calibrate all the sensors to make sure that it does provide proper feedback. Because initially when we were piloting it or running it, we were getting a lot of feedback in terms of, well, I get this sensors light up or provide indicator that I'm near collision, but I'm not near a collision, and there's no object moving in my direction, but it kind of gives me that I'm in a danger zone. So a lot of calibration had to be done to make sure that the system provide accurate feedback. For the driver support system, there was no official pilot. We just worked with Init to develop. Well, they had the system, I guess. We just had to work with them to implement it, do some fine tuning, and operate on a subset of vehicles, get feedback from the drivers, make sure everyone is comfortable, and then we just and then again, decision was made to install it on all the vehicles going forward and to activate the system on all the vehicles that the onboard computer can support it, because we have different generations of onboard computers. We've had Init since 2005, and we have now 3 generations of onboard computers. So only second and third generations of onboard computers can support it.
Got it. Quick question was sort of follow up to the previous one. So the data from these systems is stored on board and then downloaded when the bus comes into the garage?
Correct.
Is that correct?
Yes.
Okay.
But you have the option with Mobile Eye to upload the data to their cloud solution.
Right, but there's
which we opted out.
But there's no there's no real. I mean, there's no need for real-time monitoring.
No.
It's mostly used for training or for analysis of environmental management or for investigation of safety of accidents or incidents after the fact. So, there's no real reason to do anything in real time. I mean, in terms of transferring the data to the central control.
Right.
Okay. Other question. Sorry, go ahead.
No, I'm just saying, as part of the analysis or trends, we also look at any particular locations that may be more accident prone.
Right.
For example, certain locations or certain left turns may have more safety events than others. So that helps us to investigate, well, then certain locations are more maybe accident prone, and maybe the drivers need to be more careful around certain areas.
No, that's a very good point. Yes, that's really interesting. Some other questions. Hello from the Société de Transport de Laval. Very interesting. It's exceeding the speed limit part of the DDS. In other words, are you monitoring when drivers drive faster than the speed limit, posted speed limit?
Yes, it is being monitored as well by collision avoidance system.
Right. Oh, by the collision.
It actually
avoidance?
can read the signs. It's the speed signs. The system can read the speed signs.
Okay, but it's by the DDS, isn't it? Not the collision avoidance system.
No, by the collision avoidance. Well, sorry, both systems monitor speed. So Init monitors the vehicle speed, and it can provide alert when the vehicle is speeding, but it's using the map layers with the posted speed.
Right.
Where collision avoidance it scans the surrounding areas, it can see the speed signs, and then it can provide you the notification.
Oh,
But
okay.
collision avoidance provides speeding in real time back to the driver, where init provides speeding as part of the reporting and analysis. They know when the vehicle is speeding based on vehicle speed and the map or the speed layer map.
Yeah.
And then we get the reports from init to analyze when the vehicles are speeding, but it's not in real time. Where collision avoidance is in real time. My dog is barking because my kid just came back from school. Sorry.
No problem. Another question: can you access the video recording front cameras for specific analyses?
Can I open the door and I'll be right back?
Sure.
Because
Go
that's
ahead.
gonna happen. Sorry, one sec.
Lots of questions, Brendan.
Yes. No, I'm very, very happy. It's sometimes it's like pulling teeth to get people to ask anything. There's all sorts of questions.
And
Good ones
great
too.
audience too.
Yes.
Number of audience.
Very obviously this was something people are really interested in.
Hot topic.
Yeah. Cool.
Okay, sorry about that.
No problem. So can you access the video recording front camera for specific analyses?
No, because these cameras are not recording, and these are not video cameras.
Okay.
But we have video cameras installed on the bus.
Okay, that's the separate CCTV
That's a separate
system.
Correct.
Right. But
Yes.
and I assume there's one facing forward.
There is one, yes.
Yeah, of course. Yeah.
We have both on the outside, curb side, driver side, one facing forward, and there's 4 cameras inside.
Okay.
Both entryways, entry doors, driver. Yeah.
Okay. Sorry, this one's a little long. Part 1, oh boy, and then it's part 2. Okay, does the init onboard computer plug into the vehicle via an OBD2 port or similar to receive CAN bus data from the vehicle onboard computer, or are the sensors external, integrating directly with the init computer, bypassing the vehicle's computer? Not sure I totally understand.
I'm not sure if I can. It does read CAN bus data, but I'm not sure I understand the question.
Yeah, I'm not sure. Part 2 is if the init computer.
I can say that it's using J1939 protocol to interface between collision avoidance and init. That helps.
Which protocol? Sorry.
It's a J1939 protocol. It's a CAN bus data protocol.
CAN bus one. Okay. Part 2 is if the init computer receives data from the vehicle, not the sensors directly. Did that integration require partnership with the bus manufacturer?
No, we did not have partnership with bus manufacturers. I mean, the first 10 electric vehicles were retrofitted by collision avoidance.
Okay.
We work with Roscoe to retrofit. Going forward, the collision avoidance system will be installed by OEM.
Got it. Yeah.
Okay.
Okay. In terms of training drivers to respond to the collision avoidance and other safety indicators, do you continually analyze how each driver is using the system?
Yes, our safety and training, they monitor performers. They can monitor by vehicle, by driver, and yes, they provide their counseling, coaching, training continuously. And that is how we're able to see the reduction in safety events and improvement of driving performance.
So I guess the follow-on question is, so this is a new task for the training group. I mean, this is, I guess, in more traditional system situations, they would just sort of monitor when there were incidents. Now this has got a continual feed of data. Is there some sort of thresholds or something that helps the training people focus where they should be looking?
Sorry, can you repeat that question, Brandon, please?
Yeah, in other words, before you had this kind of information, this data, the safety and training folks would just use incident reports to monitor what was,
it would be reactive after the incident.
To be reactive, exactly. Here they have to proactive, but they have a huge amount of data. Is there anything that helps them triage the data to?
Absolutely.
Okay,
Yeah, we collect all the data, but the reports only provide data that is in a risk zone or in a red zone,
okay,
or
okay. So it's
we
there's sort of,
don't provide everything. I mean, we collect everything, but we only provide
gotcha,
everything that which exceeds threshold to report on.
gotcha. Okay, okay, okay. So it narrows down what they have to, the new
Right.
task they have. Yeah. Okay.
Yeah, there are different level of collision avoidance zones. So if it's in a yellow, it's just a warning. We're not even worried about it. It's only
Right.
when it's a near collision. As you can
Okay.
see here, for example, that was in the master camera or master sensor, there was a collision, near collision at 513, and you could see the driver also applied harsh braking, which
Right.
exceeded the threshold for regular braking.
Right.
Can you see my screen, by the way?
Yeah. 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 We can see it.
Yeah, as I go by, between the screens. Yeah, and well, the other thing is, I'll wait until the questions are over. I'll mention something else as well.
Okay. How did YRT quantify the benefits of the system? I guess systems. Have you conducted a study to assess the benefits?
Yes, what we've done actually, it's actually a very good question. Before we've activated the driver support system to the driver, we've activated the system on the vehicle to create a baseline. So we want to know the before and after. So the system, driver support system was operating, collecting the data, but it wasn't providing any feedback to the driver. And after a few months of collecting the data, we've turned on the system so that it can provide feedback to the driver in terms of indicator lights. We've done the training, the coaching, and we've monitored, and we saw the before and after. And I have some reports, and it is very, very impressive.
Oh, that's very cool. Okay. Do you use the DSS to commend the top drivers? In other words, positive feedback.
I can't really comment on that. It's probably our contractors who have some incentive programs. I know they do some sort of incentive programs, but I'm not sure exactly what
Right.
and how they reward.
Right. For the benefit of people who may not know, YRT actually contracts out its operations.
And like I mentioned, the number one key message to the drivers was that the system is not punitive. It's not meant to. It's just meant to improve. And once the drivers understood that the system is not meant to, punish or
right.
discipline them, it's just a support system
It's
and
a
to improve
support
their
system.
driving
Yeah.
techniques. We really got a good buy-in from the driver community.
Yeah, I was wondering that because Big Brother sort of concerns, but that's important to make sure they don't understand it's not punitive.
Mm-hmm.
Yeah. Those are all the questions for right now. Quite a lot of questions. You said you had something you wanted to add yourself.
I had something to share maybe, and Brendan, maybe I can do something in the future, but we are planning, and in it, they don't know it yet, but we are planning to pilot another system, and we call it driver status monitoring, and it monitors driver fatigue and if the driver is tired, so it monitors the eyelids if they're closed more than the next number of seconds, if the neck is turned away from the windshield for more than X number of seconds. So we are exploring that technology. We'll be piloting it on 6 buses, and we'll have the same approach. We'll do the pilot for a year or so, but then how to determine if the system is effective and providing value. It's not just to make sure that system is operating. We want to make sure that how do we know that it provides value. So our hope is also to integrate it within its system at some point. All the critical safety events when the driver was fatigued or was looking at their phone or whatnot and not paying attention for more than a threshold, we would like to record these events. We would like to put it on a map. We would like to see, if the driver was tired and fatigued and closed their eyes for, let's say, 5 seconds, then we want to see did the driver slam the brakes right after when they start paying attention. So for us, when we implement systems, we always try to collect data and make sure that we understand and make informative decisions after that. We don't implement systems for the sake of implementing systems. We want to prove the value of it.
Yeah, that's interesting. The DSS and the collision avoidance are like you said, some of those functionalities are available on cars or for the DSS, on trucks. It's been, devices on trucks that monitor mostly because of hours of driving and rest periods. The new ones you mentioned, I haven't heard of those. Are those systems that are in some other industry like trucking?
I think yes. I don't think they have it yet anywhere in North America on public transit, but they do have it on trucks.
Yeah.
In
okay.
Europe and Asia, I think, as well.
Yeah, no, I've never heard of that on transit. Well, there's not very many of the even the DSS on buses, but
No.
on trucks they've been around or variations of them have been there, and they're in order to log hours of service and so forth.
Yeah. So the region has very comprehensive traveler safety plan, and everything we're trying to do is to basically align and support that plan with traveler safety.
Mm-hmm, mm-hmm.
Technologies they support it.
No, that's very interesting. Okay, Igor, thank you very much. That was very informative. And I know you
Thank you for
can
the
see from
opportunity.
the number of people attending and all the questions. This is a winner. There's been very. I don't think I've had another webinar with so many questions. So
well, I was happy to present and answer the questions, and hopefully it was helpful. And thank you for the opportunity.
Thank you. Thank you very much. Just before I pass it, Yannicka has a note she wants to mention. I just want to mention we're hoping to have another webinar in December, early December. Totally different topic, more on the data and use of data, smart card data, and we'll keep you posted about that. But we try to cover lots of different topics within the ITS world in these committee activities. So Yannicka, you wanted to mention something.
I would like to thank both Igor and Brendan for their time this afternoon. Thank you, Brendan, as host of today's webinar. It was very informative. I've learned a lot. For those who are attending, today's session is being recorded, and the recording will be sent to you, but it also will be featured on the ITS Canada APTS Technical Committee page. Just wanted to, before I close off, thank the audience for being here today, and I hope you can see my screen. So just wanted to highlight an upcoming event co-hosted and co-organized by ITS Canada and the City of Toronto on November 7th and 8th. It's called the Technology Innovation Forum. 2 days at the BMO IFL in Scarborough. Registration is open. Registration closes on October 28th. And if you would like to attend this session, please email me and I will send you a registration link. The flyer is also featured on the ITS Canada website. And with that, that was what I wanted to say. Thank you, everybody. And we look forward to seeing you at the upcoming event or at the next APTS Technical Committee webinar. Have a great afternoon, everybody.
Thank you, everyone. Bye.
Thank you. Thank you, everyone. Okay, bye.